Cybersecurity teaching needs labs that are repeatably aligned to outcomes. Building each environment by hand often takes many horsesand drifts between cohorts. AVEGEN is a web platform that holds base box images, a catalog of services, and labs composed on top. It ties content to curriculum topics and drives deployment to local virtual machines. In this demo, I will walk through the product in the browser, then show a lab running and a quick attacker side check. After sign in, the dashboard is the hub. From here, staff and students move between base boxes the OS images lab VMs start from. They also use the service and topic catalog, lab definitions, and running deployments. Everything you see is backed by the same application, so composition and deployment stay consistent. Topics give syllabus visibility. Educators can see how catalog content maps to teaching areas, not only isolated boxes. That supports curriculum-led lab design instead of one-off machines. Base boxes are the foundation images. Lab VMs are built from, for example, Ubuntu, Debian, or Windows guest templates registered in AVEGEN. Staff can track which images exist, align them with Vagrant and VirtualBox on the deploy host, and optionally use server-side build or upload flows depending on your deployment. The service catalog is where reusable definitions live, installation and provisioning intent, flags where applicable, and links to topics. Filtering helps staff find what fits a lab. Users can search for services by source, such as manual, which means services created manually, exploited, which means services generated from ExploitDB, or walkthrough. Users can also search and filter services by operating system, service type, flag, difficulty level, or topic. To create a service manually, select Create Service and blank form, then fill in all the information in the form. Please note that the creator should be guided and trained before using this feature. Users can also create a service based on an internal walkthrough and in a predefined format. In this case, the system uses an Elm through the OpenRouter framework to analyze the walkthrough and generate the service. There are two stages to build a service from a walkthrough. Stage A analyzes the walkthrough to decide which type of service can be created, such as easy, intermediate, or hard. Select the Generate Catalog Draft button to start Stage B. This stage creates services based on the result from Stage A. At this stage, the system can generate one or more services, depending on the stage, a result. Users can review the walkthrough draft before accepting it as an unverified service in the system. At this step, users can regenerate Stage B if needed. Now, go to the Services tab. The newly created service will appear there. Please note that this service has not been verified yet. Verification is a very important step before using it in a real environment. Next, we use an open walkthrough to build a service. Different from an internal walkthrough, an open walkthrough can be written in many different ways, with different writing styles and descriptions. This is because it is downloaded from the internet, such as blogs or GitHub. Similarly, there are also two stages to build a service. Stage A analyzes and segments the walkthrough into possible service types, based on difficulty levels, such as easy, intermediate, or hard. In this case, there is only one possible option to create an easy service. To create it, click the Generate Catalog Draft button. Stage B generates the service based on the segmentation result from Stage A. After reviewing the draft, users can add it to services and wait for verification, or they can generate it again if needed. The newly generated service will appear in the Services tab. Next, we build a service from the exploited repository. The system has collected a list of exploits from the ExploitDB website, which is an open-source platform for exploits, and displays them in AVEGEN. Users can select any exploit to build a vulnerable service from it. If the process is successful, the new service will be added to the services list in the system. The process also includes the main steps, starting with analyzing the exploit to assess whether a service can be built from it. Then, the system generates the service. If it is successful, users can review the result and decide whether to add it to the system. All of these processes are performed through the OpenRouter framework pipeline. Finally, the system provides the ability to build a service from a human description. The more detailed and specific the description is, the more accurate the generated service will be. There are also two stages. Stage A analyzes the description to assess whether a service can be generated, and Stage B generates the service based on the Stage A result. Now, let's go back to the Services tab and look at what is inside a specific service. First, it contains the provisioning script. This script will be installed on the lab machine to set up the vulnerable services and configure the flag scenario. Next, it includes information about where the flag is placed. Normally, a newly created service needs to be verified. Currently, this verification process is done manually and takes about 15 to 30 minutes. Next is the labs component. This is where machine-based scenarios are stored. Each machine contains 3 types of flags: easy, intermediate, and hard, with each flag linked to a service at the same difficulty level. To create a lab, first fill in the basic information, such as the machine name, base box or operating system, RAM, CPU, and network. Next, select the Easy service, which contains the Easy flag for the lab. Then, select the Intermediate service, which contains the Intermediate flag. And finally, select the Hard service for the Hard flag. Enter a name for the lab and select Create Lab. The new lab has been created with 3 services. In the lab details, users can see the detailed values of the 3 flags. These flags are generated randomly when the lab is built. In each lab, the system also provides hints for learners for each service, such as easy, intermediate, and hard. More detailed than hints, the walkthrough provides step-by-step instructions on how to complete the lab and capture each flag. Now, let's start one lab, test it, and try to capture the flags from that lab. When we run a lab, the platform generates the workspace and drives the local toolchain. In our stack, that means Vagrant talking to VirtualBox on the deploy machine. The web UI shows status and, where implemented, streamed output, so staff and students are not blind during provisioning. To test the lab, Get the lab IP address and use a Kali machine as the attacker to check this lab and capture its easy flag. Use the Nmap tool to scan the lab and check which services are open. This lab has 3 open ports, SHA on port 22, and 2 web services on ports 80 and 8080. Access the web service on port 80. Then, check the page source, and we can get the easy flag. Go back to the Running Labs tab. We can see the running lab and its details, such as the IP address, hints, and walkthrough for that lab. After completing the lab, users can stop the lab when it is no longer needed. The system will shut down the VM in the background and clean up the used resources. Finally, users can delete the logs if needed. AVEGEN turns catalog and composition into repeatable local labs. Reduced manual time, multiple base boxes and services, runnable scenarios, and tested hosts. Thanks for your watching.